Okay, good morning once again, and welcome back to class for the last lesson. Let me say welcome to the last lesson for this course, and that will be lesson 8. However, I need to emphasize this. I just realized I don't have my headphones. Okay, that's fine. Good morning. Thank you. So, I need to emphasize this. For lesson 8, it is, I wouldn't call it optional because it's very, very important. However, it is not compulsory uh, in terms of exams. So we will not be testing, we will not be testing you on the concepts, um, particularly in lesson 8. However, these concepts are interwoven in the previous lesson. There's some kind of interplay with the previous lessons we have discussed so far in this class. So you don't have your xylabs. There's no xylabs for lesson 8. However, you still have your word, you still have your so I think we still have the I don't know, I need to I don't know how this thing comes up. So I just go here. So we don't have for lesson A, which we'll be discussing today, object and classes, we don't have xylabs. You're not required to complete xylabs for lesson 8. However, you still have your challenge activity and your participation activity um, to learn, more on these concepts. So I don't want you to to forget this important piece because this is still part of your final grades. So while this class will not, will not be testing you in the exam on this specific lesson, but you still have, you still have some concepts, that you need to take care of in your Zybo exam challenge and participation activity. And I think we have due date. Let me check my calendar. So let's talk about due dates. So that being said, now we need to talk about some important information that I think for your overall success in this course, they are very, very important. Your due dates for Zybooks activity for lesson 8 is this Friday. That's on the 24th. Yeah, exactly on the 24th of this month. That's this Friday. And all your quiz. I mean, for the people that did not do the quiz before the first exam, all the quizzes, I mean, the end of the lesson quizzes from lesson 2 until lesson 8 is also due on Friday. So you can see there's a lot of things to do this week and next week. So I need to emphasize this for you to, to plan ahead of time. And you don't wait until until the last minute to start working on your assignment. So you have all the end of the lessons. I mean, from lesson 2 until lesson 8, you have that due on Friday, 24th. You also have your Zybe labs, Zybox activities. I mean, the challenge and the participation activity as well due on 24th. So a lot of things to cover, particularly for people that did not, for you guys that did not complete lesson 1 to lesson 2 to lesson 4, end of lesson quiz. Um, by the first, by the first exam due date. Now we are moving to the second exam for this course, and that will be on the 30th of April. On the 30th of April. And one of the reasons, to be honest, one of the reasons I actually put the end of lesson, each of the end of the lesson quiz to the last, like the few last days of the semester, is the fact that it helps you to prepare for your exams. So um you can see and you can feel what the exam will look like. I'm not saying that the exact exam questions. However, it's the same structure, multiple choice. You're tracing your code. You're defining concepts. You're applying your knowledge on these concepts to solve a specific problem during the exam. So once you're doing your end of the each class lesson, and especially from lesson 5 until lesson 7, once you're doing this end of quiz, end of lesson quizzes, you're also in a way preparing for your exams. So if you have any question, please let me know. And for next week, there won't be class. So I want you to take next week, I mean Tuesday and next week Thursday, which is the exam. I want you to take this opportunity to study for your exam, to study for your exam. And your exam is just the same, it's just the same way we did for exam one. And it opens by 6 a.m. On Thursday morning, and it closes by 11:59 p.m. on Thursday. So you can take it. It's just an hour exam, 60 minutes. The same process we had for the exam one. However, for this specific exam, I will be more strict. I will be more strict for this exam because there were some violations, there were some violations in the first exam. Ensure, ensure you follow all the instruction of the exams. No mobile phones, no, your webcam should be on. Just you need a very quiet environment. So ensure all this are put in place before you start your exam. You can actually take this exam anywhere you so desire. However, we're using Monologue, so it's actually recording all the process, whatever you're doing. And there were some violations for the first exam, but I ignore that because we did not discuss this before the exam. But now, for exam two, it is very, very important you follow these rules. And if you have any question, I will be online for the class period on Thursday. Only on Thursday. Only on Thursday, please. I need to emphasize this. Only on Thursday, because that's the exam day. So I will be connecting on Thursday. If you have any questions before the exams, if you have any questions after the exam, please, you can join the call. I mean, it will be the normal class hour, I mean, from 9:45 until 11. So you can join the call to ask me any questions, to just join the class meeting and let me know if you're facing any specific challenge in writing your exam as a whole. So for check-in activity, which is our last check-in for this semester, checking it, ensure once you submit all your end of the lesson quizzes and your Zybox, your lesson 8 Zybox, ensure your grade actually synchronize well with Zybox. if there is any problem, please. That is why we I actually put this check-in every 2 weeks. The check-in is to ensure you're following up with your grades. And if there is any problem, you raise your hand and say, hey, Dami, I think there's a problem with my grade. Hey, Dami, I think I have missing the specific grade. Probably, there's a specific accommodation that you have, and oh, you have not enabled this accommodation for me, and my grade is missing. So this is the purpose. You let me know, because this semester we're rounding up already, and that will be the end of this course. That will be the end of this course after the second exam. So that being said, I think I have talked about the due date, which is very, very important. Another thing I want to emphasize, which we talked about in the last class period, I think last week we talked about that, is the cost evaluation. I noticed, of course, many people, because more than half of the class actually fulfill this survey. However, we still have few people, 9 out of 16. So we're missing about 7 people pending to submit the course evaluation. It is very, very important. Why, this helps us to say, is this course really doing what is meant to do? Are we learning what is expected to learn? And is instructor really helping you to learn? Because I said it from the first class. My role in this course as your instructor is to actually guide you, to help you, to assist you to learn these concepts. I introduce you to these topics, and you go on your own to really look into it. So these are the things I want you to discuss in your evaluation. There's also some other other places where you can actually, textbooks where you can actually put more details of this information. Anyhow, you think we could improve this course, the material, anything you think whatsoever can assist us in improving the quality, the structure of this course as a whole. And that being said, um, your all the lessons so far, all the lessons, I mean, from lesson one until until the last lesson, which will be lesson 8 for this week. I have all the lessons from lesson one. I have all this in the, we are recording. That's the purpose of recording these sessions, each of our sessions. So if you have missed any specific lesson and you're preparing for your exam, it is very important you have missed any specific lesson and you're preparing for this exam, and oh, I need to learn this concept, or I want to go through what we discussed in class and go through my materials, go through the textbooks. You will have the video recordings. You have the video recordings links here, so you can revisit that anytime while preparing for your exams. And will also be available for questions. For this week, I will be having my virtual office hour as well, but for next week, no virtual office hour. But you can always inbox me with your questions. Send me a message on inbox. Hey, I'm having this specific problem. Hey, can you please point to relevant resources or material that will help me to learn this concept more? Hey, I need you to help me trace and debug this specific code. I am more than happy to support you, and you're always welcome to ask any questions in this class. There is no wrong question, there's no dumb questions. So feel free, ask questions. Let me know if there's any way you need my help. So That being said, I will send more information about the exam too before the week runs out. I think before Friday. And I'm teaching this course as well in summer, so I'm allowed. I'm kind of busy trying to plan and prepare the next schedule for this course. So before the end of this week, I will send um, further information about the exam. So please check your announcement page. You will receive more instructions on how the exam two will be conducted, similar to what we did in exam one. Similar, extremely. It's almost the same procedure. However, you just be testing on different concepts, from lesson 5, 6, 7, um, for exam two. So questions on all we have discussed before we move to the topic of today? Thumbs up if there's no questions, and we are good to start. Thank you. Okay. So, final lesson for this course. I'm super excited. So, we'll be talking about classes and objects. Trust me, we started this conversation long time ago. I mean, we have been talking about classes from lesson two. We have been talking about how to name the classes, how to define our classes. We have been talking about objects, what are objects? Uh, Defining an object, we have been saying, oh, for this, you don't have to create an object. We need an object when we're talking about an instance method, not unlike when we're talking about the static method, that you can just access this method via the class. You don't need to create a specific object to access the static method. However, for instance method, we do need to create an object. So we've been talking about object. We have been talking about classes. How do we name our classes? These are things we have been discussing from lesson two. And, classes, objects are just the beauty of object-oriented programming language. Just from the name, object-oriented programming language. Now, objects. So you're writing your programs in modular form and in objects in different class within a class, kind of. So that's the concept. That's the general concept of objects oriented programming language, working with classes and objects. And we will talk about why with the benefits, the pros and cons. Let me put it that way: the pros and cons of object-oriented programming language. How is it different from the procedural language? What is even a procedural language? So we'll talk about all those things, rounding up this course as an object-oriented programming language. So today we are moving to the foundational level of what an object programming does, how it works. We have talked about how it has evolved, how programming has evolved in our lesson one, and we just want to build up on what we have learned in that lesson one until lesson seven in our lesson eight. Like I do say it from the beginning of this class, each lesson is a build up on what we have discussed in the previous lessons. So, what is the purpose? What are we going to learn? Why do we need this? Why do we need this specific? Why do we need this specific lesson? What are we going to learn? So we're going to describe how, we're not describing, we are revising. I will say we're revising because we have talked about objects, we have talked about classes in this class, and we are just going to revise what we have learned about objects and classes. We're going to demonstrate how you define classes and how we create objects. We are going to create objects using constructor. We're going to say, what is a constructor? What is it? These are just terms, terms and programming, and we're going to say what are the meaning of those terms, And so we are going to access objects via object reference. We'll do that on Thursday. And we talked about the dot operator, the access operator. What does it do? We talked about that in our user-defined method lesson last week. And you know, we ran up this class and we are good and ready uh, for our exam. We are good and ready for exam after this. So exactly the same thing we have discussed. We have, of course, we have talked about the difference between object reference variable and our primitive data type variables. We talked about that. I think in our lesson 4, we also discussed that in our lesson 5. So to use Java libraries, classes, dates, there are a lot of examples we have in this specific lecture notes on the predefined class dates, which is in our library. So we will see some other examples for this lesson. So are we good to start? Are we good to start? From the word, from the name, OP, object-oriented programming, objects-oriented programming, object. So it involves we're programming objects, we're using objects to program. We are writing our code in 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 a modular kind of way. And an object represents an entity in a real world that could be identified, you know, distinctly. You could identify it. So when we're talking about object, we are always talking about three important components. Three important components. We are talking about identity. It must be identifiable, uniquely identifiable. That's the point. We are talking about the states. And when we're talking about the state of the object, we're talking about the properties, the variable, the data field, the properties, the attributes. That's the word, the attributes of that identity. The attributes. Oh, your identity is what? A student. That's your student. And you have a unique identity. You have your student ID, for instance, as your unique identity in this sense. So that's, the properties, that ID, that ID, that your student ID is an attribute of your identity. And we also have the third component, which is the behavior. And when we are talking about behavior, we are always talking about the methods within this, within this identity. What are the functions? What can you do? What are the actions that object can perform? And we just gave an example of a student. You as a student, which is your identity, you have your student ID, which is your attribute. So what can you do? What is your behavior? Of course, you can register for a course. You can add a course. You can drop a course. That's the behavior of an object. So it's always defined by a set of methods. We really talked about the scanner class from lesson 1. And we talked about the scanner class that this is an instant method, and we need to create an object. And when we are creating an object, we name that object, the specific name. You can call it scanner, you can call it SRCN, like we call most of the examples we did in class. And we said, what is the method? What can this method do? What do we want you to do? We want you to what? To grab value. And we say system.aim. We want you to grab value from the user. And that system.aim is actually the method which is telling the compiler, hey compiler, stop there. You had to get this input from the keyboard. That's it. That's it. And that is just when we're talking about the core components, of an object. It must have an identity. A, it must be unique. The name must be unique in attributes of that identity. That is the features, the characteristics, the states of the identity. And now we are talking about what, again, the behavior, which is the third component. And the behavior is always defined by the action, the action, the method that this object can perform. So we use student analogy now. We say, as a student, you can register for a course, you can drop a course, you can add a course. Those are the kind of actions you can do as a student. Any question on this? Thumbs up if we're clear with this description of what an object is, how an object operates. Thumbs up if we're good to go. Only have you understand this? Do you want me to go back? Okay, thank you, Madam Sarah. Perfect, perfect. So this is the foundation of object-oriented programming. Object, we are coding, we are writing our programs, and our programs has to have these three important components. And the oriented means the specific language. Use the object form in writing our codes. So this is just another illustration of how the objects actually work. So you can see this is the class name when we're declaring class. And within that, we have this data field. And what is the name of this data field? Radius. And radius is what? That is the attributes, This is what? This is the attributes. The attributes of this class, of this cycle. And what is the method? What do we want to do? And we're saying get area. This is what we want to do. We really want to calculate the area. So an object has both states and behavior. So an object always have this attribute that defines it, and also operations that can be performed, which is called our method. And the operation is always, the command, what we want, what we want, what we want this method to do, just like the system.in. We want it to grab value from the user. System.out.print a new line. We want it to print in a new line. System.out.print. We want it to print, but we are not specifying if it's a new line or on the current line. Do you understand how method works now? So method what it has to perform, it's called to perform a specific action, a specific task. Yeah. Please print, please grab values, please calculate square roots, calculate minimum, calculate maximum. So it has to be a specific, a specific action we want our objects to do. So before we start talking about classes, why do you think writing our programs in object-oriented form matters? Why do you think it does really matter? What do you think about it? We talked about this when we were talking about the user-defined method, and we were talking about reusability, ability to reuse things. We're talking about reducing redundancy. You can call this method to do the same functions if you have similar problems at hand. We're talking about all these concepts, and that's one of the few reasons why while me as a person prefers an object-oriented language. However, object-oriented language cannot be used to solve all problems, specifically when we are looking at scientific problems or more statistical problems, more statistical problems that have to be done one step at a time, step by step. And we'll talk more about that in before the end of this class. We'll talk about the difference between procedurally and object-oriented language. So we've been talking about classes. What are classes? What are classes? We talked about this. In fact, I remember we were talking about Java class. I want a specific uh let's take let's think about the string class. Yeah, we can talk about the scanner class. So this is what this is a class. And what does this, we talked about reading the APIs. And what does this class hold? So this is always the blueprint we call class. We look at class as blueprint for creating objects. Because in here we have what? In here we have information relating to how we can, call the class, how we can use it, the different kind of method, the different kind of command within this class. So you can see now we are seeing with the constructors. We will talk about constructors today in few minutes, but I'm just showing you what a class entails. Talking about a class now, we're talking about constructors, we're talking about the methods within the class, we're talking about the attributes of those objects. How do we declare our method? How do we use a specific method in this class? So this is what the class all together, all this information. It holds together all this information. It defines the attributes of the object. That's information relating to the variable of the object. And also, it also holds information on the different commands. So uh, how do we use this? How do we check the length of a string data type, of a string value? How do we join two strings together? These are the different methods we can use in giving examples of what are the parameters we need to pass to use this method, and also giving us description, illustration of how this method works at home. Trust me, we're not going to have all this information in our head. So let's check the scanner class, for instance. That's another class, another important class in Java. And you can say, this is the scanner class. What is this class doing? It is holding. It is the blueprints. Oh, let's use this analogy of building. You have a building construction, and you have to build different detached buildings within a specific area. And the blueprint will always be your, what your architect actually draw. That's the structural diagram, the diagram of how the structure, how the building will look like. And we call that building plan in my country. And that plan gives you an idea of what we want to build, how we want to build it, what are the resources that we need, how can we get it done. And that's just the concept of the class. It's the blueprint. It's like the the the, the the dictionary. I wouldn't call it dictionary, but it's just like the plan of how you can use specific objects within this class. What are these attributes? What are those commands you can use within that specific class? So A class always define what data, what data an object holds. What operation can these objects perform? So let's go back to our node and see what we have there. So that's exactly, it defines objects of the same type. In the Java class uses variable to define data field, that is the attributes, and the method to define the behavior. Don't forget, we just talked about the three important components. Three important components when we're talking about objects. And the classes actually helps hold all this information. So like we have been talking about why this matters. And I was saying it's enable modular programming. So you don't have to write long, large programs. So it breaks those programs down in smaller chunks. So a better way to organize things in different blocks of code. So it helps to reuse in this form. And it also helps us to know what an object is doing and how the object, how the object is doing it. It is not really giving us, we don't have to struggle to to understand how the object is really working, but it gives us an idea of what an object, how the object should work, what an object. It gives us this information, and in that we call that abstraction. It support abstraction. And object-oriented programming language has five main characteristics. We will talk about that on Thursday. So importantly, the class provides special types of method known as what? As our constructor, which is invoked or called to construct an object from the class. So anywhere you see the word new, just in our, let's go to the previous example we had, the code we wrote last week when we're defining user-defined method. And here you can see we're creating our scanner class here. And how do we create the scanner class? Of course, the class. This is scanner. We have already imported the class. And we're saying, hey, what I want to write, I want to use methods, object. I'm declaring an object within the scanner class. And the name of my object, that is the identity of my objects, is what? This is the name you're giving the objects. That's the identity of the objects. And I'm saying, once I see new, once this keyword new, it is telling the compiler, here is the constructor. Here is what is the constructor. And here is the method. Here is the constructor, and here is the method. So we're gonna say, let's say, what's the difference between constructor and method? Constructor is always used to create and initialize an object. So when we're creating and initializing an object, we need what we call a constructor. It has the same name. We always have the same name with a class. So we always have the same name with the class, Kana. It has no return type, unlike the method. We were talking about value return type and void return type. So constructor is a type of method that is what? That is void return type. It does not return anybody. And we have what? The specific function. The specific function. We want this objects. That's the behavior we want this object to do. What do we want you to do here? We want you to grab values. We want you to grab value. From where? From the keyboard. We talked about methods. We've been talking about method sets. And we were talking about void returning method, value returning method in our last class. And, we said a method could be void, it could be valid. One of the methods that are void, return it constantly. It does not return any value. It's always void. Are what we call our constructor, which is primarily the purpose of our constructor is to what? Is to create and initialize an object. And it has this important keyword called new. Once the compiler says new, the compiler understands, hey, I'm working with a constructor here. I'm working with a constructor here. And immediately after that, it always have the name of the class itself, the name of the class. And that's what we're talking about, a scanner class, which is the name of the class. The name of the class itself is scanner. And this is the method, this is the function, the behavior we want this to do. And it's always like talking about grab this value from the user, kind of. So, any question on this? Thumbs up and feel good with this. Okay, thank you very much. And let's go back to lesson notes. Perfect. So this is just an example. So what do we have here? This is the class cycle. And double radius equals to 1.0. This is what? That's the variable attribute. Attribute, variable, attribute, whatever name you want to call it. And here we have what? Our constructors. And I said our constructors always have this keyword called what? New. So once the compiler sees this, he said, oh God, I'm working with a special kind of method that is not returning any value. However, it helps to initialize. It helps to initialize what? This variable to this objects. So it helps to initialize our objects. So we're putting that objects to be stored what? In a specific variable. And of course, the behavior, which is the method. What should it do? What is the purpose? Hey, I want you to perform the specific action, which is what? To return the area of a circle. And from the example we did in the last class, we were talking about how do we calculate the area of a circle, and we said it's always radius multiplied by radius multiplied by pi. Any question? Any question on this? Okay, so what is UML diagram? When we talk about UML diagram, we are talking about unified modeling language. Unified modeling language. And unified is just the same way we just talked about that when we're talking about classes, we're talking about what a class is a blueprint, and it's like a plan. And this UML, what it does, it gives us the visual diagram, visual display of how our system, how our code, how our solution will work. So it's like just drawing a plan. This should do this, this should do this. So that is what this is doing. It is telling us how the structure, what are the requirements, what do we need, how will our code behave, how will our code work. So this is like I do call this an architect. An architect, this is like a building plan before you actually start implementing your code, before writing the program. And the UML diagram helps us to actually visualize all components, important components of our solution. Especially when we are talking about building a big software development projects. Software development, how will the program runs? This links to this. This will perform this operation. Once this link is clicked, it takes me to this. How our mobile app is working, which one of the important things we've used our Java, and which is an object-oriented programming language for. So this is tells just the virtual diagram of what our program looks like and how it works. So these are examples of different defining a class, and we have been talking about this, how you define a class, you create an object, you grab those objects, save it in a variable, and uh, make it behave somewhat, use the method on it. So that being said, I think we're gonna stop here. They're just examples here. And next class, which is on Thursday, we'll round up the difference between objects and we will round up objects, classes, and we will talk about the objects referencing type and the primitive data type. But before we go today, I want us to see the beauty of object-oriented programming language. And in a way to say that, how does it work? We have been saying it works in an object way. However, when we have some statistical problem that we need to solve one after the other, object-oriented language may not be the appropriate kind of language for this kind of problems. So we'll be talking about procedural language. How does a procedural language work? When we're talking about Python, we're talking about our R, it works one after the other. So it works step by step. It's always working step by step kind of functionality to perform. So it executes one after the other, and one majorly leads to the other one. So we'll have, unlike in our object-oriented programming language, that we have chunks, this object for us maybe calling another object within another maybe calling another method within another object to work, or maybe creating another method. However, when we're talking about procedural language, it's always step by step. It's always having your variables in tables, and this will be linking to this will be providing feeding. Let me put that word. This will be feeding another point on the table. So another data point is being fed by the previous values. So this is more from a step by step kind of programming language when we're talking about procedural language. Any question? Thumbs up if there's no question, and I think this ends the class today.